Can you hear me?
Yes, we can hear you.
Can you hear me?
Yes. Sorry.
All right. So I seem to not be able to hear from this call. So if any questions, I'll have to check the Discord chat. And I think the YouTube has, I think the YouTube is lagging a little bit. So I may hear the questions a little late. So
okay, so please go ahead. Yeah.
All right. So let me begin. So, good afternoon. It's morning over here. I'm in Montreal. This is Akshay, and who am I briefly? I'm just a PhD student doing some stuff. I'm in consistency. It's my entry level, I would say, to memory consistency, not like stuff which already maybe Paul and others discussed. Um, I'm being supervised by Cloud Ruge, Joseph McGill, and been getting a lot of help from Mark Batley. A lot of things. Mark is in the room. Hi, Mark. Hope you're good. And the problem, or the stuff I'm going to discuss is pretty simple. It's a simple problem that you're trying to see if it can be tackled. What is it? Okay, so what is it? Let's say I have a compiler and it adheres to some memory model B. Let's say that's the programming language model. Let's say we allows optimizations T1, T2, T0. Great. So the compiler can do these optimizations. Great. Now, let's say I want to allow T3, but T3 is not safe. So, okay. So I'll do something. So I'm compiling and add the T3. So let's say we do and fine. But can we specify a model like this exact picture? Meaning, I get T2 in addition to T3. That's the first question. The second one is, let's say if I come up with a new optimization, let's say T4, and I proved it for T, it's allowed by T. Great. So in my old side, can simply do that. Say, okay, now okay. But the question is, when can I this new side? This should be, intuitively it seems like it should be true, but is it actually true? Some of you might not know the answer to this, but is this a rhetorical guess? So let's just take a look. The base model is SC. We want, let's say, Y3. And then for that, we say, here's a good model. It allows reordering. Definitely go. There you have it. And definitely that's the evidence of behaviors. And we ask ourselves, do we have the same set relation? It comes to optimization. Let's say right reorder this here. That's not the real picture. In fact, the picture. So even if I do right reordering by adopting a weaker model, That does not always mean I get the existing set of SCFs. And this is not just for TSO, one comparison. There's a nice survey paper, Cienko and Co. You can see the entire comparison. The NCA, this is a kind of figure. NCA and any model, and even all the other models. So what is it? Can we actually can we get optimizations from SCA? That's like first question is actually maybe we can pass. Yes. But can we retain the safety without ever worrying the safety guarantees optimization? So okay, let's try. That's what we did. Let's try. A simple let's use a mathematical model. Just to recap, it's an isometric model. It's of constraints on executive graphs. So let's say here, for instance, this is one axiom which is purely RF, cyclic, and with that you can justify that of load buffering disallowed, whereas load buffering. So what do we? Well, we thought, okay, why is this not? And that's pretty simple. It's a new behavior, isn't it? After you do the transformation, which means the some axiom out the same behavior. And so maybe it's just the axiom should give us a way to body. Okay, so let's take SC. This is just an axiom like SC, a bunch of reflexive constraints. These two highlighted ones are RB, this is capital region 4. MO is just memory order across all locations, which should straight. And let's take the test optimization reordering of memory. Just to recap, the message passing not is having a cycle. If you can see the diagram here, X1, then I can read X1, read X0, it should be. So, is reordering memory allowed? Simply reorder reads, and you get a nice sequential justifying the sort. And axiomatically, what does that mean? Again, a recap. In the same outcome is just allowed by RB, HB as a composition, and after transformation, there is no cycle. So, can we try? Let's say, which is median suggestion. So let's just remove that. The question is, does that work? Well, it certainly makes a reordering sound. That's no doubt. But what about other optimizations? Now, let's say, just like T4, I come up with a new optimization, say, so now I have a right here, which does nothing, and the right is just the same as initial value. XYZ are all 0. So I should be able to just delete it. It should not matter, and the program should behave as the same. So this is okay under SC. It's certainly fine under SC. It doesn't give any problems, but it doesn't work for our model. And that's simply because if you see here, we don't have this PO immediate edge here. Therefore, our BHV disallows the message passing outcome. But now we have the PO immediate edge on deletion. And great, okay, we don't have this optimization. So it's not safe. So simply removing this PO immediate edge or that axiom involving PO immediate edge was not enough. So what can we do next? Maybe it was not just PO. If you just look at the example, maybe it is PO, any PO. That means there can be any event in the middle. And this is z equals 1, but it can be even z equals 0 or any number of routes. Does that work? Well, let's see. So let's do a bunch of optimizations. Or let's just say it's transformations. Some may not agree it's an optimization, but let's say. So I have these 3 threads. Let's do a simple inlining. I inline a T3 with T2. It's fine. I guess we all know inlining is allowed under SC. Gives no issues. SC also allows redundant right elimination. So you see here, I can simply remove z equals 1. And here we have the same program as before. And then now I can use my new optimization and say, I remove z equals 0, and now I have this program. So this series of optimizations, is this allowed by our new model, which now just says, oh, the PO edge is removed. Well, not true. And that's simply because let's take this behavior. Let's say again a equals 1, b equals 0, and let's say my final value of the right should be of z should be 0. So in the original program, I'll need an MO that actually enforces this. But if you can see here, this is actually disallowed even with our new model due to RB MO HV. So there's an RB here, MO HV. You want to say in terms of cycle, there's a clear cycle here. But then the final program that we have, there's still this PO immediate edge, which is part of PO. And so we actually allow this outcome. And we don't need any memory order of between writes of Z. So because Z does not exist and it's the initial value 0. So we have that pretty satisfied. But we see there's a new behavior allowed. So it's not so simple. And what do we do? Well, okay, you can say it's our observation, or if you carefully even observe by drawing out execution graphs for every set of read values and final write values, you'll notice that the final elimination, that's the only transformation is not safe in these examples. So maybe we should divide the problem, maybe. Let's just say, can we guarantee complete? Can we guarantee I get safety of all forms of ordering optimizations? We asked that question. We said, okay, let's not worry about elimination and introduction. Let's just look at simple reordering, deordering, and so on. Okay, it looks like a simpler problem, but it may be simple in terms of what's done in practice today, maybe, but maybe tomorrow we find a way to design optimizations which actually juggle pieces of code. Now, if you briefly notice here, this is like a load buffering kind of pattern, which is converted to a sort of a message passing pattern. And if you look at the read values, as far as sequential consistency goes, you see there is a clear subset. So it could be that such a transformation is safe under SC. Maybe I find a way to do this tomorrow, and I maybe prove it safe under SC. But for such optimization, how can I actually guarantee the safety on models weaker? I may have to reprove, and that may be really hard. Maybe sometimes not impossible, or maybe some proofs are like just 10 to 12 pages, and so on. So, what do we do? Well, that's exactly what we're doing. And just as a brief recap, that the previous transformation like this, which is kind of bananas, because it's very difficult to explain what exactly happened. It could be different forms of inlining and reordering and reordering. But we can establish that it's actually unsafe under the new model with PO. And that's simply because if I just look at A equals 1, B equals 1, I have an HB cycle here. It's clearly disallowed. But here, I see it's just a message passing outcome with the PO edge. So it is allowed. But we don't know about SC by just saying the reads. And so this is the kind of, or the flavor of stuff we are trying to do. But of course, in a more theoretical sense, we can't just go through examples one by one. But our idea is sort of preparing for the future in the sense like we have these memory models, yes. But the problem is that if I come up with optimizations tomorrow, especially ones which are based on global analysis and so on, then I may have to prove individually for each model out there, or if any new model I propose for a programming language, I may have to reprove the safety guarantees. And maybe that's not required. Maybe we can actually prove something between these models, which ensures that I don't need to reprove these safety problems. So that's what we're going all the way in. So we're asking whether all transformations, let's say I take SC and I take these local reorderings, read, write, and I derive a model. So the question is, do I get all other possible optimizations from SC? So if something I prove safe in SC, do I get it directly for free in the model I have? And I think this is one aspect which is important to know, because let's say we come up tomorrow with models which address the out of thin air problem for some reason, but it certainly would be difficult if I come up with better optimizations as the years go by, but then I cannot, but then it's not safe in the models which I have, which address other problems. So I think having this property is something useful.
Actually, can you hear me?
Now I can hear you. Now I can hear you.
I'm sorry, but I'm actually just contacting you to say we'll have to cut you off soon because we are running a bit late. And I'm sorry, I'm not going to be able to ask the audience to ask questions because of the time constraints. I'm sorry. So we've got Akshay's email address there, and I'm sure you could also ask him questions on Discord. So please let's thank Akshay for the talk.